Lesson 3.5, Solving Inequalities with Variables on Both Sides. When solving variables on each side, it's very similar to solving equations. So with this description right here, I want you to write it down exactly as it says. It says, some inequalities have variables on both sides. When solving inequalities with variables on both sides, solve like you would solve equations with all the variable terms on one side of the inequality symbol and all the constant terms, meaning numbers by themselves, on the other side of the inequality symbol. So here we have some examples working with inequalities with variables on both sides. Notice they want us to solve the inequality and then we're going to graph the solution. So here we have 4m minus 3 is less than 2m plus 6. So I want to get all the variables on one side. I'm going to get the numbers by themselves on the other. In this situation, I'm going to get the m's on the left side and the numbers by themselves on the right side. It doesn't matter which side you put the variable on or the numbers by themselves. I'm moving m to the left because it's easiest to subtract 2m to each side. So we have on the left 2m minus 3, which is less than 6. Then I can add 3 to each side. So now what I'm left with is 2m, which is less than 6 plus 3 is 9. We still have not put m by itself, so we're going to divide each side by 2. M is less than 9 over 2. You can leave it as a fraction or put it as a decimal of 4.5. So now we need to graph this. So I have my number line. When we're working with fractions, you can set it up as this. Here we have 9 over 2. Here we have 10 over 2. 11 over 2. This is 8 over 2, 7 over 2. So 9 over 2, if m is less than 9 halves, so I would have an open circle at 9 halves, and I would shade to the left because m is less than that. So notice I have shown my work here, and then I've received the final answer, which m is less than 9 halves, or again decimal 4.5, and I've graphed it. Let's go into the next example. Here we're going to be working with the distributive property because we have 2 parenthesis k minus 3 and parenthesis, which is greater than 6 plus 3k minus 3. I'm going to distribute the k, 2 to the k, 2 times negative 3. 2 times k gives me 2k. 2 times negative 3 is going to give me negative 6. So 2k minus 6 on the left, which is greater than, let's combine like terms here, 6 minus 3 is going to give me 3 plus 3k. So again here, I want to get all the k's on one side, all the numbers on the other. I'm going to move k's to the left, numbers to the right. Again, it doesn't matter if you move k's to the right and numbers to the left. I'm going to subtract 3k first to each side. 2k minus 3k gives me a negative 1k minus 6, which is greater than 3. I now am going to add 6 to each side. So what I'm left with is negative 1k is greater than 9. I still need to get k by itself, so I'm going to divide each side by negative 1. Dividing by negative, we're going to flip the sign, so I have k is less than negative 9. That is what I've solved for, so I now need to graph it. K is less than negative 9. I will have an open circle at negative 9. K is less than that, so I will shade everything to the left. K can be any number less than 9. Okay, so for these first two examples, we have solved the inequalities and we have graphed the solution. Let's go into two other examples here. These examples are a little bit different, and you'll see here after we solve them. They are similar in the fact that they have variables on each side and you have numbers on each side. So we do want to get variables on one side, numbers on the other. So I have 2x minus 7 is less than or equal to 5 plus 2x. I'm going to subtract 2x to each side. So here I have 2x minus 2x. That becomes 0. So that cancels on the right and the left. So what I'm left with now is negative 7 is less than or equal to 5. Now, notice how we have negative 7 is less than or equal to 5. We have to think, is this a true inequality? Is negative 7 actually less than or equal to 5? Yes, that is true, because negative 7 is less than 5. So we're going to call this, since the variables cancel out and this is a true inequality, that negative 7 is less than 5. We are going to say all real numbers. We actually could too, if you think about it, if you take negative 7 is less than or equal to 5 also, if we move all the numbers on the other side, adding 7 to each side, is 0 also less than or equal to 12? That is also true. So negative 7 is less than or equal to 5, but also 0 is less than or equal to 12. So when we fully solve this out, your answer is going to be all real numbers because both of these are showing it's true. Let's look at the next example. We have 2 parenthesis 3y minus 2 and parenthesis minus 4. So we are going to be working with the distributive property here. 2 times 3y is going to give me 6y. 2 times negative 2 is going to be a negative 4 minus 4 on the left, which is greater than or equal to 3 times 2y is 6y. 3 times 7 is 21, so plus 21. Let's combine like terms on the left. So I'm going to have 6y minus 8 is greater than or equal to 6y plus 21. We want all the variables on one side, numbers on the other. I can subtract 6y to each side. Those cancel. So what I'm left with is negative 8 is greater than or equal to 21. Is that a true statement, negative 8 greater than or equal to 21? That is not true. Also, if we keep making this so that numbers are all on one side, I can add 8 to each side. Actually, no, I'm not going to do that, so I'm just going to stop where I'm at. Since that's not true, this is going to be a no solution problem right here. Okay, so when it's true like this, all real numbers. When this is a not true situation, there is no solution.